How can small differences in economic growth rates lead to huge changes over time? That's going to be through the power of compounding. And it's one of the strongest impacts in the entire world. And it affects not only countries, but can affect your own personal income and finances as well. You'll actually take a closer look at the compound interest formula in your finance classes a little bit more in depth. Here, we're just going to go ahead and do an approximation just to start us off. So the power of compounding allows small rates of growth to turn into substantial increases in income over time. So compounding by itself is the ability of growth to build on previous growth, which is why it is so powerful. So let's go ahead and write this down. So compounding is the ability of growth, to build on previous growth, And the reason why compounding is so powerful is because of this fact right here. So compare this with simple interest or simple type of compounding. So with simple interest, you're just going to be gaining a percentage based on the amount or principal that you put in. So if you have $100 and you get a 10% simple interest, you're just going to be gaining $10 every single month or every single year. That's not going to be a lot of money over time. However, if you get 10% compound interest, when you put $100 in, you're going to get $110 in the month or year after that, and then you're going to get 10% off of that $110, not that same principal of $100. So essentially with compound growth, your money is just going to keep on growing and growing and growing, and it's going to be building on the previous years or previous periods growth. So it's very, very powerful impact. So let's go ahead and take a look at a few specific numbers with compounding. And remember that this is going to be very true for both countries and for your own personal finances. So suppose that you have $1,000, you're very, very happy, you have money, and you're deciding to put it into a bank that gives you a 5% annual return, or you're deciding to put it into the stock market, which will give you a 10% annual return. So if you take this $1,000 and you put it into your bank, that gives you 5% annual return and 5% compound interest. At the end of 35 years, you're going to have $5,516. That's going to be a very, very big amount. You say, hey, I've more than 5 times multiplied my money, so that's going to be a very, very good result for me at the end of 35 years. However, if you took that same $1,000 and found somewhere that gave you 10% compound interest, like the stock market, you're going to notice that at the end of 35 years, you're going to have roughly about $28,102. So almost 6 times more than what you had under the 5% annual gain. This is just a small difference of 5% in terms of growth rates, but you notice that, hey, you have almost 6 times as much money at the end of 35 years. So this is essentially why policymakers and government officials are so concerned with finding policies that are going to induce economic growth and have high sustained positive economic growth rates, because this is the fact that's going to be apparent. We see that, hey, we now have incomes that are $28,000 versus incomes that are $5,500. So the standard of living is obviously going to be bigger with the higher economic growth rates. So what we want to go ahead and do in this particular section, we've sort of proven already that having high economic growth rates is going to be good for citizens and the standard of living. What we're going to be interested in is calculating these numbers right here. So how close can we get to this 5,500 and how close can we get to this 28,000? And in order to do so, we use something known as the rule of 70. The rule of 70. So you might have heard the rule of 70 also be called the rule of 72. I use the rule of 70 because it's a little bit easier to divide those numbers in my head, but the rule of 70, rule of 72, they pretty much tell us the same exact thing. And the rule of 70 is equal to 70, it's going to be a constant number, and we divide it by the annual growth rate. Annual growth rate. And with the annual growth rate, we typically keep the annual growth rate in whole number form. So we don't need to convert it into a percentage. So 10% would just be a 10 right here. 5.5% would be 5.5. There's no need to divide that by 100 to get the growth rate on the bottom. And this rule of 70 will tell us exactly how long it's going to take our money to double. So 70 divided by the growth rate, how long is it going to take our money or for any value to double in value? And the rule of 70 itself is just going to be an approximation. So because it is an approximation, we'll never get these specific values right here. So this 5,500 and this 28,000, we'll never get these specific values. In order to do so, we need to build up the time value of money, and we'll do that once we hit our money chapters and also in your finance classes. But here, we just want to go ahead and get as close as we can using an approximation with the rule of 70. So one thing to note about the rule of 70, because it is approximation, we're going to notice that it is more accurate. It's more accurate for small growth rates, more accurate for small growth rates, and also for shorter time periods, and shorter time periods. So here, as with any approximation, the smaller the growth rate, the shorter the time period, the better our approximation is going to be. So let's go ahead and use those two numbers that we saw on that slide with a 10% annual gain and a 5% annual gain using the rule of 70. So let's go ahead and build this up in a new color. So let's go ahead and say with a 10% annual gain. With a 10% annual gain. So how long is it going to take for our money to double according to the rule of 70? We just go ahead, plug the numbers into our formula, 70 divided by 10, and this will tell us that it's going to take 7 years for our income to double. 7 years for income to double. So that tells us that every 7 years, our $1,000 should be doubling. So we can go ahead and use the specific numbers that we have. So we start off with $1,000. And then, how much is this $1,000 going to become? We double, so times 2. Our money becomes $2,000 in 7 years. And we can put another column right here that just says total years, total years. So here, so far, at the end of 7 years, we have $2,000. At the end of another 7 years, how much money are we going to have? Because it is compound interest, we're not building the 10% off of this $1,000 anymore. We're now building this 10% off of the $2,000 that we have. So this $2,000 becomes $4,000 in another 7 years. So another 7 years. So in total time, in 14 years, we have $4,000. We've quadrupled our money in 14 years. And then we continue down this process until we get to 35 years or as close to the 35th year as possible. Remember, in economics, use the numbers that are being provided to you. Try not to extrapolate numbers that are in between. So here, this $4,000, it now becomes $8,000 in another 7 years. So this is going to be our 21st year. Then this $8,000 becomes $16,000. So once again, doubling in another 7 years. So this is 28 years. And then finally here, we go ahead and take a look at the final year. 16,000 times 2 will give us $32,000 in the 35th year, in 35 years. So with all of this, how close do we get to that value that we saw previously on the slide? The correct value is $28,102, but the approximation based on the rule of 70 will give us $32,000. So we're overestimating a little bit, but it's still a decent approximation using the rule of 70. So this is a very, very good thing for us to say, or just to go ahead and use it as an approximation. Let's go ahead and do it with a 5% annual gain. So here, with a 5% annual gain. With a 5% annual gain, how long is it going to take for our money to double? Well, because it's half of 10 years, it's going to tell us that, hey, it's going to take us twice as long for our money to double. So 70 divided by 5 will give us 14 years. So 14 years for money to income, for income to double. And then we continue on with the same process as we did right here. Once again, we want to get as close to as we can to the 35th year, and we're only going to be able to carry this out twice. So our $1,000 once again becomes $2,000 in 14 years. So here, total years, we can put it right here, total years. This is going to be 14 years. And then once again, we carry this out, this $2,000 based on compound interest now becomes $4,000 in another 14 years. So here, we get to the 28th year. So in 28 years, we'll have roughly about $4,000, and that's as close as we can get to the 35th year because that is what the problem or information does provide to us. Still, a pretty decent approximation of the 35th year where we have $5,516. So once again, with this rule of 70, just giving us an approximation of how long it's going to be taking our money to double. We take 70 divided by the annual growth rate, and we build up a table as such. However, there are a few things that we want to do with this sort of rule of 70, doing a little bit more of a complex example and comparing two countries' growth rates against one another to see how fast countries are going to reach and match incomes or GDP per capita with one another. We'll take a look at that in the next few videos, so I'll see you guys there.